Okay, so once again, let's talk about this. If you have two intersecting lines, where they intersect is going to be the solution. If you have two lines that are parallel, there's going to be no solution. Oh, that's not parallel. Parallel, no solution. And if you have two lines that are perfectly, totally overlapping, you have infinitely many solutions. Okay, that's for graphing. Solutions of systems equations. So I've given you time to do number 2, so I'm going to walk through it now. Let's start with the purple. So I'm going to start with this top one. I want to get it into slope-intercept form, meaning y equals mx plus b. So I'd like to get the y by itself, so the first thing I'm going to do is subtract x from both sides. That way I have 2y equals negative x plus 4. But wait, I want y by itself. Right now it's multiplied by 2, so I'm going to take every term and divide by 2. That way I have it as y equals negative 1/2 x plus 2. Alternatively, for this one that I'm changing into slope-intercept form, you could find the x-intercept, you could find the y-intercept. Those are 2 points, you could graph it that way. That's how we did it yesterday with our chapter 2. So to graph this one, we look at the y-intercept. The y-intercept is the plus 2. It's the number without the x. So I go up to 0, 2. 4 divided by 2 is 2. So I start with this equation, and I want to get it into the slope-intercept, right? Y equals mx plus b. So I need y and only y by itself. So first, I'm going to move the x to the other side. 2y equals negative x plus 4. But there's a multiply by 2, so I'm going to take it, divide by 2 every term. So this one turns into y. Negative x divided by 2 is the same thing as 1/2. Negative 1/2 x. 4 divided by 2 is just 2. Okay, so this is my y-intercept is plus 2, so go to plus 2. And then my slope is negative 1/2, so it means down 1 divided by 2. So negative, so when you look at a graph from left to right, like we read in English, we look at the slope. So as we go left to right, we should have a negative slope, meaning going down. So down 1 over 2. Oops. Down 1 over 2. Okay. So this is my first line. What's wrong?
I don't know how I did that wrong. I did it the other way. Isn't it
So it's a negative 1/2 slope, meaning as you look from left to right, it should be going down like a slide. We always read graphs going left to right when we're talking about slope. So going down, negative slope, coming up, positive slope. So the next equation, I'm going to do this one right here in blue. I'd like to get y by itself, so I'll subtract 2x on both sides. So I have negative 3y equals negative 2x plus 1. So I'm doing it in different colors. If it's hard for you to differentiate between the two colors, just let me know kindly, and I can switch it up. Just to make sure there's a distinction. Okay, last thing, to get y by itself is being multiplied by negative 3. So if I go through and divide every term by negative 3, I can get y by itself. So this is the tricky part. Let me zoom in a little more. So negative 2 over negative 3, the negatives cancel out, and I'm left with positive 2/3 x. And then plus 1 over negative 3, so I'll just be subtracting 1/3. It's a 1 over 3. 1 divided by 3 is 1/3. So this is a not so nice. I try to make it so you only have integer slopes and intercepts and integer intersections, just so it's a little easier for you guys. Yeah, try to make it so less confusion, so you understand the process. I'm trying to test the process more. So negative 1/3, that's about a third of the way between 0 and negative 1, so negative 1/3. And then the slope is 2/3, so up 2 over 3. So 1, 2, 3, up 2, so 1, 2.
Up 2 over 3?
Yeah. Yep.
Then you go up by...
So what I did,
Start in a point, so you go up.
so I'm starting at this point right here.
Yeah.
Oh, this is really hard to see. Let me pick a different color. Okay, so I want to go up 2. So this is up 1. This is up 2. And then I want to go, so I'm at negative 1/3. So if I go up to positive 2/3,
It's 2 comma 1.
2. And then I want to go over 3. 1, 2, 3. So that's my second point was right here. So, but they cross right at this point,
2 1.
which is 2 comma 1. That is the intersection point. Yeah.
Wait, where
I did not mean for
where
it to
you
do
know where
that.
start again?
So I started at my,
Up to, right? For the first one?
I started at negative 1/3, which is right here.
No, for the first line.
Yeah. So I started at 2. So I start at 2. I start at 2, which is right here. And then I go down 1 over 2. That's really hard to see. Did you see how I did that? Let me do it again.
No, I got it, yeah.
Okay. Start here, down 2 over, oh my god, down 1 over 2. Down 1 over 2.
I don't know if it's
So it should nicely cross at 2 comma 1.
like not at all.
Do we see?
Or do you not? Yeah, which is what's that? Two. Okay, so you only went up 1. I don't think you go up 2.
Okay, let's try the second one. Woo. Actually, let's. I'm gonna have us do 8 and 9 instead. I'm gonna have us do 8 and 9. So we're not like, we're only gonna graph the system. We're not doing the other stuff because we didn't do it in class. Okay, so we're only graphing the equation. So I would like to graph number 8. The first one is in slope-intercept form. All right, so my slope is negative 1, and my intercept is negative 2. So I start at 0, negative 2. 0, negative 2. And then I go down 1 to the right 1, because it's a slope of negative 1. Okay, I'm going to give you like 10 seconds or so. I want you to try to graph the other line. And then tell me what the solution is. Where are they intersecting? Gotta get in slope-intercept form. This is my y-intercept is 4, negative 4. Slope is negative 1. What? They are parallel. So wait, parallel lines, the solution is? No solution. Okay, yes.
I get 1.
Sure. No solution. Huh?
You go to the top again.
Yeah. So you either can have them intersecting at one point, which is one solution. They're parallel, so no solutions, or they're totally overlapping, so there's infinitely many solutions. So we've done 2 where they're overlapping, and you just have to find the coordinate where they're crossing. All right, we did 1 where they're parallel. Not to be a spoiler, but we're about to do number 9. Can you guess what the solution's gonna be? Infinitely many. Okay, let's do it. Surprise. Okay. So I'd like to get this in slope-intercept form. So I have 2y. Do you need me to go up again? Are you good? 2y equals 8 plus x. I would like to get y by itself. So I divide every term by 2. So we have to draw our own axes. Maybe something like this. Yeah. Something around that. So I go up to positive 4, and I have a slope of up 1 over 2, because that's a slope of 1/2. And then if I draw the blue, right, so it's always my second line, it's exactly overlapping with the first. It's kind of hard to see, but this one would be infinitely many solutions. Okay, so that's a review of the first section, which is graphing to solve. Now, there are the second lesson is substitution and elimination to solve, which is algebraically. Then the third section is inequalities. Where are they overlapping? Those solutions. All right. Am I good to go on to the next page? Need a little more time? Okay. So if this one's confusing, you know, like, hey, this would be a good section for you to review. All right, solve each system of equations by using substitution. I really didn't give you enough room. Should probably have another sheet of paper. So we are using substitution. So what is the difference between substitution and elimination? Maybe like in general, the word substitute, what are you doing when you substitute? Maybe a basketball game? What do you do when you substitute in a basketball game? Replace, right? You're literally switching out two players. You're replacing one player with another. When substitution here, you're replacing one variable with another equation. Versus elimination. If you eliminate, right, the Sweet 16 tournament coming up in March, if someone's eliminated, they're literally gone. They're not there anymore. So if you use elimination tournament, you're eliminating, making one variable disappear. So we want to solve this one by substitution. So what I would like to do is, if I could get y by itself, I can make an equation, then plug it in for the y below. So if I subtract 2x from both sides, I see y is equal to 4 minus 2x. And now that I know what y is equal to, I can go ahead and plug it in for y below, solve for what x is, and then get y by itself. What? 16th, oh yeah, so it should be the 19th. Did I write the 18th?
Yeah.
Yeah, I don't know. Okay, thanks.
Oh.
You're not even in that class. Okay, try solving number 1. We discussed the process. I want you to do number 1.
No, that's the other class. I was just reading. Yeah, that sucks. What process? 16.
I have 2 finals and
I have 2 on there. Yeah.
Oh, what ours on?
I only have 2 on there.
16.
That's so nice.
Monday is the
My
first
winter
one.
break starts.
But that's so scary, the first one.
First one, my
A week from
only
yesterday.
Okay, I wanted you to try it. We talked about the process. You probably
I got 3
didn't have time.
3x plus 8 minus 4x.
Did you guys find a solution?
Oh, no, not yet.
Okay. Okay, so I have 3x plus 2 times 4 minus 2x is equal to 1.
We could have done it.
3x.
Is it negative?
I'd have to get x by itself first.
Yeah, but we can do either, right?
It's normally you use substitution if like one of the variables has no
So, yeah,
coefficient.
but I'm saying, like, in general,
Oh,
like,
yeah, so like this one, get x by itself. Yeah. I see what you mean now. Alright, so plus 8 minus 4x equals 1. Negative x plus 8 equals 1. Yeah, because that's the right side. Negative x equals negative 7, so that means x equals 7. There's a lot of chit chat. Do we have questions about this one?
Oh, okay.
Being on task. Yeah.
And then don't you put the 7 in the rest?
Right. Now that we found the 7, I can come up here, plug it in, and find what y is equal to. Y equals 4 minus 2 times 7. 4 minus 14.
I don't know why.
Negative 10.
I kind of like not listen because it's confusing.
Uh,
Like, I'm being so serious.
Nobody will know if you're listening at all.
But now we know.
but I mean, I do. I see when people aren't paying attention, when they're on the same page the whole time. Or when they're whispering, or when they turn around and talk.
I genuinely don't know why it's confusing me, but like I honestly think it's because there's not a lot of room. I'm not even gonna lie.
It's probably because there's not a lot of room.
I'm trying to like do it on this. Like
Okay.
I literally get on the task and I understand it.
Okay.
It's just, like,
There needs
I
to
don't
be
know
a
what's
page
happening.
load to file.
So, I don't know, that's one thing to keep in mind is like when we took the chapter 2 test, all we're doing, we're chapter 2 for like a couple weeks before, And now the final is cumulative from like all the way back to September. Okay. And remember in September when like it was hard because you forgot because all the stuff we were learning were from like 2 years prior, right? So I'm like trying to make sure we touch everything and like review everything. That way it's like kind of fresh in your brain. Yeah, not. Maybe the second one will be a little easier. We'll do number 2 and then we'll move on to the other examples. Maybe it would make more sense.
Maybe can I just watch and not pay attention, but
That's
writing it out,
and that's
writing it
fine.
out on the other piece of paper and like.
That's fine. Because I have the solutions uploaded, so.
I'm just gonna watch and like take it all in.
Right. That's fine. Okay, so Ruby's question earlier was like, wait, we solved for x on number 1 and we got y, or I'm sorry, we solved for y, and, you know, y equals blah blah blah, and then plugged in what y was equal to, solve for x first. We could solve for x first. And then plug in and then find what y is. So I'm gonna add 3y on both sides because the easiest way to do substitution is pick one of the variables as a coefficient of 1. So here I have x equals 9 plus 3y. Now that I have what x is equal to, I can plug this in right there. Plug it into the second equation, because if you plug it into the first equation, you're just going to get the same thing. You're going to get 0 equals 0, 9 equals 9. You have to plug it into the other equation. Yes?
What if I did x equals 3y plus 9? Does it matter?
No. This is the commutative property of addition. 1 plus 2, same thing as 2 plus 1.
Yeah.
Yep. Plus 2y equals negative 1. So I have 9. Well, 3y plus 2y is 5y equals negative 1. So if I subtract 9 on both sides, 5y equals negative 10. And then lastly, to get y by itself, divide by 5. So we find negative 2 for y. Awesome. Once you find one of the variables, you plug that number back in and find the other. So I'll plug this back in here. And I have x is equal to 9 plus 3 times my y value. So that's 9 minus 6, which is 3. But I have to make sure I write my solution at the end. Negative 2, comma 3. And that is my solution. That is the answer. What? Yeah, sorry. Yeah, that's good. It's always x and y. Yeah, good one. Okay, substitution. Good. The other method we have to know is elimination. Awesome.
You said like you didn't put the solution
For
for the final bucket.
I haven't put it on yet. I'm working on them. Yeah. I'm trying to get all my class tests graded and then do that. Yeah. I'm almost done. I'm on my last class test. I have all the homework graded. All right, now we're using elimination. So what this means is you want to literally have one of the variables eliminate when you add the two together. So number 10 is nice because I already have opposite signs for the coefficient in front of s. So if I add my two equations together, I get 5r plus s minus s cancels out equals 25. And then to get r by itself, divide both sides by 5. And you see r is equal to 5. And once I have that, I can plug it back into either equation, either the top or the bottom, and get s by itself. So if I plug it into the top, maybe I should pick a different color. Plug it up to the top. So I'll have 2 times my r plus s is equal to 5. So I have 10 plus s is equal to 5. So I subtract 10 on both sides to get s by itself, and I see s is equal to negative 5. So I'm going to give you the x and y's. Those are the only variables I'll give you, because then you know the order to write it. It goes, A, B, C, D, R, S, T. So r is before s, so that's the way we'll write it is 5 comma negative 5. That would be the solution. So elimination, you just want when you add, you just want your variable to eliminate. The issue is number 13, if I just add them, my k's don't go away. So with elimination, sometimes you might have to multiply one or both of the equation by a number. That way when you add them, they will eliminate. So if I eliminate my bottom equation by negative 1, what happens? Yeah, multiply every single one in this line by -1. So now when I add them, the k's will go away. And I'm left with -j is equal to -6. Oh, multiply both sides by -1, and I get j is equal to 6. So the trick was, we had to multiply everything by -1, that way they have the opposite signs, and then I can add them and they will disappear. Okay, so I have what j is equal to, I can plug it in up here, 3 times 6 minus k equals 10. 18 minus k equals 10, so subtract 18. Negative k equals -8, which means k equals 8. Let's see, jkl, so j is first, so 6 comma 8 would be my solution. Okay, questions on elimination? Do you want to do one more, like a harder one, or do you feel okay? I mean, there's examples. I mean, you have your practice test, your test. I try to make it easier for myself, because imagine number 13, if I would have done 3j and 4j, I would have had to multiply the top by like 4 and the bottom by 3, and one of them had to be negative. So I'd try to go the easier one.
What's it called? What's it like? Could you like 17?
Sure. Oh, well, I'm not going to give you a fraction like that. How about 14?
Multiply by 2 and then drop the top one by 2.
14?
Yeah.
So if you multiply the top one by 2, what happens? If I multiply the top one by 2, so I'm going to write it down here. I get 4x minus 2y equals -8.
So the whole thing is
So when I add them together, so okay, this bottom line in green is this top line multiplied by 2. Okay, so I add them, that cancels out, and I'm left with 0 equals -2. But wait, can 0 ever equal -2? Right, this is a no solution because both variables cancel out, so that's a no solution. So this is like kind of like the graph. If we have one solution, cool, they cross once. If I have a false statement at the end, there's no solution. If I have a true statement at the end, there's infinitely many solutions. So 16, if we look at 16, all right, so multiply the bottom by 2. That's promising, that's good. I'd rather it be easier than harder. So plus, it's good. I'd rather it make more sense now than less sense. Okay, so I rewrote the top, I rewrote the bottom line right here after I multiplied by 2. And then if I add them together, everything goes away and I'm left with 0 equals 0. Since it's a true statement, this would be infinitely many solutions. Let me zoom out so you can like see both of these. So those are like our 3 cases. Number 13, like we came up with an x comma y coordinate. That means we had 2 lines that cross once. Number 14, we had a false statement at the end, which means no matter what x you plug in, they will never be the same, so there's no solution. These would be your parallel lines. Versus 16, we came up with a true statement at the end. Everything canceled, but we got like 0 equals 0. Maybe you'll get like 5 equals 5. Right? As long as it's a true statement, that would be infinitely many solutions, because that means you have 2 equations and they're exactly overlapping. You can't see my 2 pens because they're exactly overlapping versus parallel versus crossing.
Infinitely many solutions the same as all real numbers.
No. 2 different terms. Okay, so that's 2 of the sections. Ready for the third one? Woo! Yeah. Okay. So, solve each system of inequalities by graphing. So we started doing this yesterday. But we had 1 inequality. Now we're graphing 2 inequalities at the same time. So we're graphing 2 inequalities at the same time. So first, y plus 1 is less than -x. I would like to have it in slope-intercept form. Makes it way easier to graph. Subtract 1 from both sides. So if y is less than -x minus 1. Okay. So is this going to be, whenever you have an inequality, you ask yourself, is this solid or is it dotted? Solid or dotted? What do we think? Dotted, because it's no or equal to. So I have dotted line, right? So it's going to be a dotted. I'm going to draw my line, but it's going to be dashed or dotted. Doesn't matter, it just can't be solid. So I have my B, my y-intercept is -1. So I go down -1, make a point. My slope is -1. Where is that -1 coming from? Felix, what do you think? How do I know my slope is -1?
There's a 1 in front of the x.
Exactly, there's a -1 in front of the x.
Over to the right one.
Beautiful. So I'm just gonna draw it like this. Oops. Draw it like this. So kind of like dashy, dotty, whatever. It's easier if you have a ruler. Okay. There's my first one. And I would like to know which side to shade, because this is an inequality. Inequalities must be shaded. So something cool would be, technically, if I ask you a question like this is testing you on 2.6 as well. So on your final, I'm going to try to get the more bang for my buck. Meaning, if I can ask you a question that tests you other places to make your test shorter, I'm going to try to do that. So this would be a great way to test you on section 2.6, graphing inequalities. Well, here we're graphing two inequalities on the same graph.
0, 0.
Ah, 0, 0, because it's not on my line, so I can go ahead and test it. So I'll plug in 0, 0 is 0 less than -1. Let's see, Jackson, will you sit up? Jordan, sit up. Sit up all the way. Thanks.
So you shade above.
So 0 is not less than -1, so that's false.
So you're gonna shade down.
So since that's false, I have to shade on the other half where this is not, where the point is not located. Yeah. Okay, so notice, I put the dot on my graph, and then right here, this is testing. Like, that's all the work you really need to have. Put the dot, test it. Cool. And next, y is greater than or equal to 1. Okay, so dotted, solid. Solid, how do you know? Because it's more equal to. If I make you say it enough times, you'll remember. Okay, and can we show with our hands? What's this going to look like? Flat. Y equals 1. It's a flat line. Constant y. Okay. Has no slope. No, you're not. This is a hard one. This is a review. Because I didn't really focus too hard on like y equals a number and x equals a number last year. So this is a harder one for a review. Yeah, harder one. True. But it can be overcome.
So if we use 0, 0, then it's not so shade above as well.
Cool, I can plug 0, 0. Is 0 greater than 1? Nope. So that means I shade above it. Good. So wait, how do I, if I shade it, how do I show my solution? What's my solution going to be?
It's the shaded twice.
Yeah, the stuff that's shaded twice. So if you shade this part extra dark, that shows that's the solution. Or you could like make an arrow and say solution. The solution is the overlapping area. All right. I want you to try number 2. Give you about like 20 seconds. Really give it a shot yourself. Okay, the way I think about x is greater than -2, it's a constant x, which means you're at a certain x, and the whole time it's a constant x equals -2, so it's a vertical line, just to make sure we're starting off correctly. 2. If I pick my point, 0, 0, right, it's not on the line that I chose. Is 0 greater than -2?
Yeah.
It's true, so I'll shade the half with 0, 0 in it. Okay. Do you need more time for the second half, maybe? Yeah. Okay. So ideally, I want it in y equals mx plus b form. So I divide everything by 2 first. My gosh. No, why is it freaking out on me? So the second one is in y equals mx plus b form. I have my y-intercept of 3, so I put a dot at 3. I have my slope of, let's see, up 3 over 2. So since that would be over, exactly, since that's off my graph, I go down 3 to left 2. That way when I connect them, it will be a positive slope. And it's going to be a solid line because it's not equal to. Next step, I pick a point that's not on my line. 0, 0 is real cool because you plug in zeros for x and y, so a lot of things cancel. Makes the computation much easier. So look, is 0 greater than or equal to 3? Nah. So you gotta shade the other half where it is not. If it was true, I'd shade the half where 0, 0 is. Since it's not true, I shade the other half. And then my solution is just where they overlap. So this, oops, I don't want to use that color. So the solution is this part right here where they're overlapping. All right. Let's try another. Oh my gosh, I'm making reviews to get a good grade. Shame, shame, shame. Let's do number 5. Because this is graphing. Ooh, I don't want it to be absolute value of y though. Hold on. Dang it. Let's do number 3. Let's do number 3 instead. Number 3. What? Nice one. Haha. Haha. No. Okay. Yep. So try number 3. Yeah. Yeah, you just grab both. That's great. So this one is going to be purple. Has a -3 intercept and slope of 2, so up 2 over 1. This is going to be solid because it's an or equal to. And since it's an inequality, we must shade. Please don't lose points for not shading an inequality. Pick a point. Let's try 0, 0. Oh, what? Which one do you do? I like picking.
0, 6.
Okay. It's like that's like up here.
Maybe I want it to be up there.
Okay. You can do 0, 6.
I love the number 6.
Is 0 less than or equal to -3? No. Alright, pick 0, 0. That's not true, so I shade the half where it is not.
Oh, so you just take away the x and it's 5 minutes.
What? If I plug in 0 for y and 0 for x, it turns into 0 is less than or equal to 2 times 0 minus 3.
Oh.
I should show that. Turns into that. And then the second one.
But it's true, right?
0 is not less than -3. -3 is less than 0, yeah. So if I pick +2, slope -1 over 2, -1 over 2. It's a solid because it's an or equal to. Do you have a question? Are you explaining? Okay. Just pick a point that's not on the line. So if I pick 0, 0, it makes it nice and easy. But the issue is if this went through 0, 0, I could not choose it to plug in. Okay, is 0 less than 2? It's true, 0 is less than 2. It is. So we will shade underneath where 0, 0 is located. And then the solution is where they overlap. What if my two areas don't overlap? No solution, exactly. Perfect. Those are two options. Either they overlap somewhere, some area, or they don't overlap, no solution. So this would be the solution right there. Okay, questions? Yeah.
So once after you finish like the first one, so like on at the point where I did 0 is less than or equal to -3. So what do I plug into the second one?
Talking about the blue one, the blue equation. So I plugged in 0, 0 as well because it wasn't on. Like since it's not on this line, it's doable. A number I can't plug in 0, 2 since it's on my line. I'm trying to pick a place in my area to decide like which, do I shade above or below? That's what my whole idea.
0 for the y and 0 for the
Yeah. I pick 0, 0. It's not on my line. So I plug in 0 for x, 0 for y, and then see if I get a true statement at the end. If it's true, I shade the half where the point is. If it's false, I shade the other side where the point is not. The other half where it's not. So this is a good place to stop. We've covered a lot, like we reviewed a lot. Mark down. If you're confused by a certain section, make sure you go over it. Like, make sure those are your focus. Don't study things you already know. Go over the things that you should know but don't.